Let us move on with the next speaker, who is Roman Suvorov, project lead from Samsung AI Center, and he will speak about image neural editing 2021. And in Russian, it is like editing images with the neurals. What new things do we have? That is something that I like more. Thank you very much. My name is Roman Suvorov, and I'm project lead in Samsung AI Center in Moscow, and I will talk about neural editing of images with example of projects that we have in our center. And though it is a pretty general overview, I will try to highlight key engineering or research and development insights, thanks to which everything started working. Well, it's clear that everyone has tried editing images, adding colors or adding texts there, and there are tools for that, but these tools are usually low-level tools. So what would we like to have? For example, if we want to change the posture of a person or the time of the day after the image has been shot, or if we want to alter the image or copy the object and put it against another background so that it can look well. We can do it with the existing raster editors, but that will take too much time and special skills. And let's be frank, no one is developing landings or some simple websites on assembler. So we need good tools for editing, and happily there are these tools. They are generative models. And recently, huge progress has been done here. There are a lot of alternative approaches developed. And in my presentation, I will speak about GANs, generative adversarial networks, and autoencoders. We will have a look at different classes of methods, but they will all work with some noise that can be concentrated how many times you wish. There are images, and there is some user input condition. Let us start with one of the classical approaches, when we just generate pictures out of nothing. GANs for this stage are composed of two neurons, generator and discriminator. Generator is trying to make the image, and discriminator is trying to understand how well it looks. And the first work in this area is devoted to the new architecture of the generator. So the guys there wondered whether they can come up with a generator that would generate an image so that pixels will not be dependent on the neighboring ones. So can a picture be generated in this independent manner with all the convolutions 3 by 3 that will suit image editing and so on and so forth. And it turned out that it is possible and it works well, and there are advantages of this approach. For example, with this approach, you can glue images so that the glue line is, the blending line is not seen, and you can have other algorithms developed for this class of generators that work in a more stable manner. The next class of methods, which I believe is the most popular, is image-to-image transformation. Here belongs the segmentation or depth assessment, evaluation. But for image editing, I believe what is more interesting is when a generator receives additional user experience. And the most useful, I believe, function of editors is interactive segmentation. And different editors actually have different kinds of segmentation, and every click or point determines whether something suits the region in the image that should be included or excluded out of it. And then we have a new picture with a new mask. The feature here is that it needs fewer clicks to have a high quality choice, and it does not demand to launch another procedure. It is possible with a special training procedure and also the generator architecture that would include pre-trained blocks that I will talk about in detail a bit later. The next task is after we copy an object and embed it into a new picture, a new image. But as a rule, the lighting parameters are different between the old picture and the new background. So we would like to automatically have the brightness, contrast, mask set, and that task is called harmonization. And my colleagues have come up with a method that can cope with this task better than the previous methods do. And the improvement here goes through adding into the architecture pre-trained blocks from neuron HRNet that was initially trained for classification task. That is a very popular architecture. But guys have come up with a trick to save these pre-trained weights and expand the possibilities of this neural network so that it can receive in the input not only the image but also additional information. And the trick turned out to work pretty well, and therefore the coloring can be set much better. And what else you might need to do with an object? You might need to delete it, and that is the task of in-painting. So you choose some area, it is deleted, and then the generator kind of restores the pixels so that the whole picture looks natural. The task is pretty popular. It has been solved for many years by several teams, but we are still far from fully solving this task because it might seem simple, but actually there are a lot of basic questions of this process, and we have improved again the solution of this task. We understood that the generator should be loaded pretty well during training, and there has to be a strong augmentation and wide aggressive masks. And neural networks are usually trained in raw pictures, and initial masks are generated on the way to restore the content of that mask. So the second important component here is a generator with a large receptive field. And convolutions from the central domain went well in our case. And the third important comment is social loss, social supervision. And instead of VGG that is traditionally used for this task, we found out that if we use ResNet that is trained for semantic segmentation, the generator will pay much more attention to global structural aspects of the picture than some fine texture things. And that is what is needed. And therefore, the quality that we have received in popular H marks was better. And interestingly, we managed to move really further ahead in painting the repetitive structures, repetitive patterns, and structural backgrounds that have always been a problem. And the second advantage that we receive is that this generator is trained in low-resolution pictures, or images 256 by 256, but then it can process pretty high-res images. And the next function is about style transfer or coloring the whole picture differently. So that is when one picture describes the content and the other describes the style, and it gives out the third picture where the main contents still stays, but it has the new style. For the training, no marking is needed, though for the majority of previous methods it was needed. And this method, initially, it was elaborated for photorealistic style transfer, but it will also do for the artistic one. And we managed to reach that through special training where style is generated, or there is a style exchange or swapping, and the consistency of the global structure is provided for by special laws that is based on segmentation mask preservation after the transformations. So now we have covered the methods that were developed specifically for image processing. But there are other methods that initially were developed for video generation. But as for many of them, one picture is enough to begin running. We will look at them here as well. The first thing is neuro avatars. Neuro avatars, super hot topic of the recent couple of years. A lot of teams have worked on that, and the fight is to make the avatars to high quality with a low resolution, and so that it can work on mobile devices. And another thing that they fight for is the simplicity to build an avatar, so that no personal 3D model is required for the person with an ideal lighting and so on and so forth, so that one picture is enough. And my colleagues have succeeded in developing a method when there is one photo and then new photos start to be generating of the same person but in new postures. And this method generates images in pretty high resolution, and it can run on mobile real time. And we managed to reach that through decomposition of the image for high frequency and low frequency part. High frequency has certain details, that is high resolution image. It is generated once when the avatar is created and during training. And low frec is generated for every bit of the video, and as one image is enough to start work, we can then fix the posture or expression of the face. A logical continuation is a transition from portrait photos to full body photos. The method here follows another scheme. Here the basis is parametric model simple X of a human body, of mesh-based body shape, and it enables us to generate photos of random people in the preset posture, and it also allows to create an avatar from one photo of a real person and change the posture or clothes a little bit. The basis of this method is the texture that is generated, and it is a very popular method, the style GAN, and then the texture goes through Simple X, thanks to which it receives the human shape, human body shape, and then it is converted into a habitual picture, normal picture of a human being. And again, one photo is enough, and it can be used again to pose adjustment and redressing. Another method is also based on style GAN, but modified one. It was initially developed to generate time-lapse video. It enables to create endless time-lapse videos with non-existing landscapes, and also take a real picture, only one real picture, and make this video out of it. And we can also change the lighting or weather. The architecture is also based on style GAN, but it is modified in such a way that information on static and movable objects and dynamic parts of the pictures that are changing should be separated so that they belong to different variables. And that is also the work that, for the first time ever, posed a question that a real picture for editing with the help of StyleGAN can be processed so that latent code could get to the real space, because there can be different options. So at that point of time, it was first touched upon. Now there are many works of that kind. And there are many more projects and developments of our centers. And one of the largest is neural rendering. That is how to generate scenes without using a 3D model at all. So we have just a set of images at the input, and then some scenes can be created. And guys learned to render semi-transparent objects better, to generate soft objects like clothes. They learned to manage the lighting after the image was shot. And in conclusion, I would like to tell you a couple of words about our center. We are aiming at long-term research and development first and foremost, and not all projects of ours have deadlines, strict deadlines for implementation. That depends on the phase of the projects, of course. But generally speaking, these conditions are maximally comfortable for the research. And our center is mainly focusing on computer vision, but also generatives and segmentation and 3D reconstruction, and Anton Kanushin will talk about it later. And there are also people that work on audio processing and machine learning theory. That is an area of work that is less present, but the results are pretty good. And if you love to go deep into this subject and you can do it yourself with the freedom that is given to you, please contact us. I believe we will have food for discussion. And a lot of developments, and practically all that we are doing, sooner or later gets to open source. And on the slide, you can see the links to repository of our center, and all the works, all the developments that I have mentioned are present there. So I recommend to go there to see what we have. Thank you very much for your attention.
Yes, Roman, thank you so much. I have a question, and I don't know that person, but I will read it out. Yeah, I would like to say big thank you. But the question is, how GAN receives the information in pixels, in neighboring pixels in one-to-one. Roman, yeah, we are a little bit late. Yeah, and there is an addition. And could you please tell us about spectral notes?
Минуты это невозможно. Первый вопрос про
Yes, about one-to-one convolutions. It's generated it's a position coding accepted by the generator, or like fair attributes and position coding. And that's enough. That's number one. And other convolutions inside the generator, you need to move to the spectral area, spectral space, and change it in a simple way. Then move back to spatial dimension, use ordinary convolutions, and alter it. And then you can take the global recitative field. Well, and stability in local stock. Yes. Roman, thank you. I hope that those the person that asked that question found answer to this question. If not, the person will be able to get in touch with you.